so the last time we were here, we were discussing percent composition, and what we were dealing with firstly is a situation where you're given the formula for a compound and you're asked to determine, excuse me, the percent composition of each element that is present in the compound. And it's a relatively simple process. All we do is we add the total molar masses of all the elements, or each element in the compound based on the formula, and divide it by the entire molar mass of the compound times 100%, and that gives you the percent composition of that particular element. So that's a relatively simple process. Now, what is not as simple is the reverse. In other words, to get from the percent composition data the formula for the particular compound. So as you're going to see, it's not as simple as the other way around, because there are a couple of steps that are involved. Because the first step in this process is that we have to basically determine the moles of each element based on either the percentage data, if that's provided, or the mass of each element, if that's provided. Depends on which, all right? So that's the first step. Then the second step is that you have to obtain the whole number ratio of moles between the different substances or the different elements in the compound. And the way we do that is that after we determine the number of moles, we divide each of them by the smallest number of moles. And those numbers will give you the subscripts for the different elements in the empirical formula for that compound, all right? Once you do that, then basically you can get from there to the molecular formula, and we're going to discuss how we do that later on, all right? So what we have here basically is a summary of the process by which, if you're given the mass percent composition data or the mass of each element, you can determine the empirical formula. And let me just say here that in this process, there's some other things that you'll have to look out for, other tricks of the trade, so to speak, and I'm going to make sure that I point them out to you while we're doing a couple of examples, such as the examples that you're looking at here on the screen. So the first example here, they gave you some information here about this compound phenol. They gave you the composition data, the mass composition data, 76.57% of it is carbon, 6.43% of it is hydrogen, and the rest, 17.00%, is oxygen by mass. And the question is asking for you to determine the empirical formula. Okay, so what I'm going to do is get out of this, go to my writing application here, and the first thing I'm going to do, I like to do this in a tabular form. I think if I do it in a tabular form, it makes it, more presentable and organized. So I'm going to draw a table where at the top of the table, I'm going to put the symbol for the different elements that are present: carbon, hydrogen, and oxygen, all right? And then the first row, oops, I hate when this happens. What in the world? Okay, you know what? Let me restart. Okay, so as I said before, I'm going to, okay, what's going on here? Okay, carbon, hydrogen, and oxygen, all right? And then we have the columns here. And then the first row here, I'm going to put the percentages, right? Now, let me just say something here. They gave you the percentages, and it's important that you remember what the percentages represent. They basically represent the mass in grams for every 100 grams of the compound, right? So basically, what we're going to do is assume that we're working with 100 grams of the compound. So by making that assumption, what that means, therefore, is that the percentages that are given, the numbers that reflect the percentages by mass of each element, would actually equal to the mass in grams of each element for 100 grams of the compound. So basically, in this row here, I'm going to express the percentages as mass. So for the carbon, that would be 76.57 grams. For hydrogen, that would be 6.43 grams. And for oxygen, that would be 17.00 grams. All right, so those are the masses. The next step would be the moles. So to get the moles, we know what to do. This is something that we learned earlier in this chapter. We take the mass in grams and we multiply it by In this case, in the case of carbon, 1 mole divided by 12.01 grams, which is the molar mass, all right? In the case of hydrogen, we take the 6.43 grams and multiply it by 1 mole over 1.008 grams. And in the case of oxygen, 17.00 grams, we multiply that by 1 mole divided by 16.00 grams. So we have to work out each of these. So in the case of carbon, that would be 76.57 divided by 76.57 divided by 12.01. And according to my calculations, oh shoot, I messed up. Let me do this again. 76.57 divided by 12.01. So work this out. You're going to get 6.3, according to my calculations, 6.376 moles. And then we do the same thing for the hydrogen, 6.43 divided by 1.008. And according to my calculations, this will be equal to 6.379 moles. And then in the case of oxygen, 17 divided by 16, and that is equal to 1.063 moles. All right? So that's how we do that part. So the next part, as I said before, is to determine the simplest ratios for these numbers right here. And the way we do that is that we basically identify the lowest mole value, which in this case would be the 1.063 moles, and we divide each of these numbers, including this one, by that number, the 1.063 moles. So of course, when this is divided by itself, you're going to get 1. Here you're going to have 6.379 moles divided by 1.063 moles. And here we're going to have 6.376 moles divided by 1.063 moles. Okay, so in the case of carbon, we divide 6.376 by 1.063, and according to my calculation, this works out to be equal to 5.998. The mole units will cancel out. And then in the case of hydrogen, it's going to be 6.379 divided by 1.063. And according to my calculation, this works out to be equal to 6.000. And of course, this here would be 1. So basically, what we can do is that because 5.998 is very close to an integer, we can round this up to 6. This would be equal to 6, and this would be 1, of course. So therefore, we can say that the empirical formula would be C6H6O, right? Each of these numbers, the subscripts, and the one here are these corresponding numbers for the elements, all right? So that's basically how we work this example here, all right? Okay. I'm going to stop. I'm going to stop this video here, and then the next video we'll be looking at the next example. All right. Until next time.